Okay, so as in the last video, we could only discuss the two concentration terms which are very important, of course, and which are volume related, which means we could found there the volume, and since we found there the volume, which means they were affected by the temperature. If we increase the temperature, the volume will be increased. If we decrease the temperature, the volume will be decreased, which is Charles equation, Charles law, right? So now see, we discuss about volume by volume percentage, which means we need to take the volume of solute per unit volume of solution. Volume of solution represents volume of solute plus volume of solvent into 100% since we are finding the percentage. Then we found, or we discuss, or we learned the formula for finding the weight by volume percentage. So as initially I told, the first part represents solute and the second part represents solutions here. So weight of solute per unit volume of solution into 100%. So in today's video we will gonna discuss these both as well, and we will gonna complete the concentration terms related to volume today. So what we need to discuss today is molarity and normality, which are of course very important terms. So here I am going with 3, which is molarity. Let me highlight it. Okay, so what is molarity? As the term suggests itself, there is something related to moles, right? Let me write this here. Molarity, something related to moles. Related to moles, okay? And since this is volume related, which means the volume will come here too. And since this is volume related, of course it will be affected by the temperature, right? It will be affected by temperature, okay? So yeah, this is something related to mole since the name suggests itself, molarity, right? So there is something related to moles. Secondly, I said we're gonna find here volume too since this is volume related, and if we're gonna find here the volume, which means it will be affected by the temperature, it is dependent of temperature. Okay, so now the formula for finding the molarity. Molarity is always represented by capital M, of course, right? So capital M, which means molarity, is equal to, as I told, it is something related to moles, as the name suggests itself, molarity. So number of moles, which is denoted by N, of course, upon volume. Number of mole of solute per unit volume. Okay, number of mole of solute, this you need to remember, number of mole of solute per unit volume in liter is what we call the molarity. Okay, so number of mole per unit volume of the solution. So here we found our third formula as well. Now see, we can actually derive the unit for molarity too, right? We know that number of mole has a unit of mole, right? Mole, and the volume unit is liter, right? So what does it become? It become mole per liter, which is equal to capital M. Now see, sometimes you have uh, molar solution, bimolar solution, trimolar solution. What does mean by that? Let's understand. If you have a molar solution, which means the molarity is one molarity. If you have semi-molar solution, which means the molarity is half. Semi means half, right? Or you can write m by 2. If you have for suppose bimolar solution, which means your molarity is 2 now, 2m. If you have trimolar solution, your molarity is 3, so 3m. Okay, so if you have decimolar solution, deci means 1 upon 10, right? 10 power minus 1, and 10 power minus 1 means 1 upon 10, 1 upon 10 m, or you may write m by 10. The molarity will be 10th part of it. If you have centimolar, centi is 1 upon 100, right? 10 power minus 2. So this would be m by 100. So now you can find of any prefix. If you remember the prefix, you can actually find any molarity. Now see, we discussed that molarity is equal to number of mole per unit volume. Now see, volume actually will be of course given in the question when they're gonna ask us to find the molarity, but how we're gonna find the number of mole? See, if they would have given us the mass of the solute, so number of mole would be equal to mass, given mass actually, of solute per unit molecular mass of it. Molecular mass of solute. This is what we learned in the first chapter, right? When we were discussing about the stoichiometry. Number of mole is equal to given mass per molar mass. If they have given you the volume of solute, you can actually divide that given volume by molar volume, and molar volume is equal to 22.4 dm cube. So you can actually write here n is equal to given volume that too of solute, since we are discussing here about solute, right, per unit molar volume, which is of course equal to 22.4 dm cube or liter, right? So here we were finding the number of mole of solute. That's why we have taken given mass and given volume of solute only. So initially when they will gonna give you a question, they will not give you directly the number of moles in it. They will gonna give you either the mass of the solute, then you can actually divide that mass by its molar mass and then find the number of moles, or they can provide you with the volume of solute, then you can actually divide that volume by the molar volume, which is 22.4, and then you can have number of moles, and then you need to put the number of moles in this formula and divide the number of moles by volume of the solution to get the molarity, right? So I guess we can discuss normality in the next video. We have completed molarity today. However, in the next video we will gonna learn about the normality, which is very important topic. And in normality is only one concentration term where you're gonna find three formulas, where you're gonna use three formulas in a formula. So this is something people find difficult, but yeah, I'll make it easy for you guys.